Let's take a look at how the Volt's revolutionary electric drive system works. We'll start with the vehicle, and at the heart of the 2011 Chevrolet Volt is the battery. The vehicle is built around a large and very capable traction battery. We use DC cables to transfer the power from the battery to the power inverter. The power inverter then converts this DC energy from the battery to AC through the AC cables and sends that power right into the drive unit. Next, the drive unit drives the vehicle through the half shafts and out to the wheels. The engine, which is coupled to the front end of the drive unit, holds 9.3 gallons of 93-octane fuel in the fuel tank for extended range driving. Now, let's fly into the drive unit and take a look at what's inside. You see the large traction motor on the left, the generator is to the right of that, and the gear reduction is shown down to the half shafts. The engine is to the right in the background. Inside the electric motor is a planetary gear set. There are also 3 hydraulically actuated clutches, 2 inside the traction motor and 1 inside the generator. The speed of the motor, generator, and the engine of the Volt is shown at the right of the screen, listed as M, G, and E, with the vehicle's speed shown above. The first thing we're going to do is apply the clutch that holds the ring gear still. What this does is it allows the traction motor to have a 7-to-1 gear reduction. So as we start driving, up to a speed of 30 miles per hour as an example of low-speed driving, the traction motor is providing all the power to the wheels through the 7-to-1 gear reduction. As we accelerate further, we'll go up to 70 miles per hour as an example of high-speed driving. We're pulling all the energy from the battery in order to drive the vehicle at this 70 mile per hour speed. You can see the motor speed climb through the 7-to-1 gear reduction. The motor speed is running about 6,500 RPM, and while that provides great dynamics for an electric vehicle, the promise of the Chevrolet Volt is an electric vehicle that can go further and do so as efficiently as possible. And to meet that challenge, we've patented the idea of a 2-motor EV drive. Here's how it works. So what's going to happen in the 2-motor EV drive is we connect the generator to the ring gear through that clutch, and then release the clutch that held the ring gear still. Now the generator can actually operate as a motor turning the ring gear. It's going to come up in speed, and the motor speed is going to come down to about 3,250 RPM. The generator is at about 1,500 RPM here. The motor and the generator operate together more efficiently than the motor alone, and have the ability to drive the vehicle at speeds up to 100 miles per hour. When the battery charge is depleted, then the Volt's 100% electric operation is over until the car can be plugged in again to recharge it. The Volt can continue driving in extended range operation, using fuel in its tank and the engine as its source of energy. At low speed, the Volt uses a combination of 1-motor electric operation and series operation. Here, we're going to hold the ring gear with a clutch, and the vehicle launches into electric mode. Then the generator is hooked up with the engine kicks on and operates with 1 motor driving the vehicle. The key thing happening in this configuration is the engine is only connected with the generator, a process that is great at lower speeds during stop-and-go city driving with the engine turning on and off. For driving and accelerating on the highway, the system pulls power from the battery. So for example, when accelerating up to 70 miles per hour, the engine and generator will come up in speed in order to maintain the average power of the vehicle. And with just a little pull from the battery during these driving events, the experience feels very electrified, even when driving in extended range mode. To get the most efficiency at highway speeds, we're going to go from this series configuration to a combined 2-motor driving mode. The first thing that happens is the clutch to the engine is released. The generator is hooked up to the ring gear and the ring is released. You will notice speeds dropping on the motor, while going up on the generator. Once the generator and engine synchronize, they can be connected, and we've achieved a combined 2-motor driving operation. This entire process is done without the driver really knowing any of it happens, while offering 10 to 15% improvements in efficiency on the highway. The motor operates on power from the generator, and the engine turns both the generator and the ring gear. The speed of the engine is still independent of the speed of the wheels though, so it can be adjusted automatically to the optimum speed for the most efficient operation. For driving up a small grade, like a freeway overpass or hill, the generator and engine speed will increase while the motor speed will decrease. In this case, the battery will provide some of the added power as needed, while you can continue to drive the Volt smoothly on the road. With 4 modes of operation, Volt's electric drive is truly an innovative system that delivers electric performance and outstanding efficiency.